Hi, I'm Elisa with the Good Docs Project, and I'm excited to teach you a little bit more about Git today. Let's get started. Today's presentation is Git for the True Beginner. Hopefully that's what you are, because that's what we're going to do today. We're going to get into a high-level overview of Git. We're not going to get into details or the specifics of how to use it. This is just to introduce you to some of the key concepts about working with Git so that you can make a good future contribution to the Good Docs project. What we're going to cover today is, first we're going to talk about what is Git in general, why is it so cool, how does it work generally speaking. We'll also get into some of the key terms and talk about common workflows that you might see when you're working in a Git system. And then lastly, we'll talk about how you can use Git in a docs as code system, since most of you coming to our project are probably interested in how Git works for documentation. So let's get into it. Okay, well, let's get started by talking about what is Git and why it is cool. Okay, start with the definition. Git is a distributed version control system that allows people to contribute asynchronously. That's quite a mouthful and really complicated, so let's break that definition down and make it a little bit more digestible. Let's start with distributed. Distributed means that copies of the project are in many different locations and on many different machines, not just one central location or machine. For example, our Good Docs project, the templates project, is in our central repository on GitLab, but it's also on Deanna's computer, and it's also on my computer, and Tina's, and Cameron's computer. So it's on many different computers at the same time. Second, version control. A version control system shows you different versions of your file as they changed over time. We'll talk a little bit more about what that means later, but for now, just know that it means tracking your changes to your project as it changes over time. And lastly, asynchronous. This means that contributors don't have to work simultaneously to contribute, although they can. But what it means is that we can all be in different places and in different time zones while we contribute. Contributors can come and go, and they can contribute anytime, anywhere, and make little contributions here and there. And the project can continue without all of us coordinating together all the time. So it's really cool like that. Git can contain snapshots of your complete project at various points in time. You could kind of think of it as being a little bit like a time machine for your project. Yeah, that makes it sound like it's even cooler than it really is, but that's really what it does. You can go back in time to see the way your project used to look, or you can visit parallel timelines. It's just cool like that. And in fact, just to illustrate why Git is cool, let's go back in time even further to the Stone Age of software development in the 1950s through the 1980s, before the days of version control. In those days, there was no way to roll back bad code automatically. Oh, so you pushed some bad code that broke everything and you need to fix it? Well, I'm sorry, but that's too bad. You had to remember what you did, what change you made that broke it, and unroll it by hand. That sounds pretty painful to me. Also, if you wanted to work on the same section of code as someone else, you either couldn't or you really had to do some heavy planning and coordination beforehand. And programmers just don't like to do that kind of coordination, right? I'm just kidding. But yeah, that's painful. Also, let's say you liked some of your old code from the past, code that's no longer there, but you have no way to go back to it and see how you solved that problem in the past. What if you liked that code, but it's gone now? Well, that's just too bad. So these were all things that you really just couldn't do in the Stone Age. So let's fast forward a little bit to the 90s, when an early version control tool called Subversion came out that solved a lot of those problems. But it wasn't perfect, and its main flaw was that it used a central repository to store its code. When you're working in a central repository where the code is contained in one place, that means that when that machine or that place goes down or becomes inaccessible, like say you can't access the machine through tunneling in through SSH or through your VPN service, like because your VPN went down, darn, you just can't contribute to that code. You're unable to work that day. A central repository becomes a single point of failure. So if that repository goes down, nobody can do anything until it was up and running. And that makes things really slow and painful. Okay. Another thing is that if you wanted to do an experiment to see if some new code practice could be good or bad, that wasn't easy to do. Branching was crazy difficult, so it was hard to experiment and mess up without hurting the central repository at the same time. It was possible, just pretty difficult to do. And then if you wanted to fork the project and take it in a new direction and try something totally different, but keep the good work that had been done so far, that just really wasn't easy to do. Or again, it just took a lot of coordination with people. So all of these things just kind of put a damper on creativity or made it harder or too brittle to contribute. But now we're in the future. We have a solution to all these problems, and its name is Git. So let's talk about some of the problems that Git solves and what advantages it gives to us. So one of the nice things about Git is that it gives you the ability to store your code. If you lose one copy of your project, it's okay, because Git acts as a backup because it's stored on many different machines at the same time. Another thing it does is it gives you the ability to restore your code. If you pushed some bad code, or maybe you liked your old way of doing things better than the new way, you can just restore the old version. Another thing it does is it allows you to compare your code. You can see what changed from one version to another, and that's really important for troubleshooting any kind of breaking changes that might have been introduced with a specific code push. Another really great feature is that you can collaborate. Everybody can work together on the same project at the same time or at different times, and you can also review each other's code before it gets merged in to ensure that it is of high quality. You can experiment, which means you can clone and fork the project where you can mess up and experiment all you want without worrying about impacting other people's work. Okay, so Git is awesome, right? Well, let's talk a little bit more about how Git actually works. I'm going to give a high-level overview, but also talk about some of the key vocabulary terms related to using Git. And in order to illustrate that, let's say we have an open source cookbook project where everyone uses Git to contribute recipes to a collaborative cookbook. And that cookbook is called Awesome Open Source Cookbook. Just a quick sidebar to mention that Git really could do this project. Git is not just for tracking code, it can also track text files like recipes as well. So it's capable of doing lots of things. All right, going back to the awesome open source cookbook, we've got Frida, who is the project owner. Maybe she started the cookbook and set everything up for the project so that other people can contribute. And then we have Ken, who likes to contribute cake recipes, and Anna, who likes to contribute frosting recipes. If you want to take the analogy back to code a little bit, you could think of Ken as maybe being a back-end developer and Anna as a front-end developer. And they all work together to make an awesome project together. So let me introduce one key term to start with, and that term, you've heard me use it a couple of times already. That's the term repository, or sometimes called repo for short. A repo is basically a folder that contains all the project's files and its version history. So in this case, we've got a folder called Awesome Open Cookbook, and it contains the files with our recipes in it. So maybe it contains a carrot cake recipe, a red velvet cake recipe, and a yellow butter cake recipe. So I chose for this example JSON files, which is a kind of text-based format that is really good for recipes. But really, you could do any kind of simple text format, and Git would be just great at tracking those. Anything like code, which is simple text files, and things like that, like .txt, that would be a format that could work really well. It won't do so great at tracking something like a Word document, because those are binary files, and so it's not going to really do much good tracking the changes of files like that. But it can at least store those kind of files. But yeah, that's not really where it succeeds. But yeah, so I need to give some more definitions here. All right, so let's say we have Ken, who is interested in contributing some cake recipes to the awesome open source cookbook. In order to start contributing, he needs to make a clone of the project, which is a full copy of the repository that is on a contributor's local computer. So to get started, he's going to take that open source cookbook and he's going to clone it to his local machine, which will be his working copy of the repository, and which is where he'll do his work and make all of his contributions and things like that. I also need to explain a couple of terms related to that. You'll see these terms pop up, and I'll explain them in even more depth later, but you also need to be aware that the original project, the one that is stored, that Frida maintains, that one is called the upstream repo, which is the central repository to which all the project contributors push their changes and pull down other people's changes. And then we've got the downstream repository, which is Ken's clone of the repository, where he makes his changes to the project. Okay, so once again, just keep those concepts in mind. Upstream is the original source repository, and downstream is Ken's local working copy on his machine, his local machine. Okay, let's move on to talking about the contributing process. So let's talk about branching. Now, this is the hardest part about understanding Git. So once you understand this, you can say that you really understand the basics of Git. So what a branch is it's an independent copy of the files that you can make changes on. Every project has a main branch or a default branch, and then contributors create new branches that stem off that original branch. At the Good Docs project, most of our default branches are called main. Other projects might have different names for them, but that's pretty typical to use main as the name of your central branch. So let's say we have Ken here, and he wants to contribute to the awesome open source cookbook. And he has decided that his red velvet cake recipe, the one that he contributed recently, needs some more improvements, needs some tweaks. So he's going to check out a new branch called Red Velvet 2.0. And this is where he is going to get to work. He's going to sit over in his test lab kitchen, making all those improvements to the recipe. And he discovers that the red velvet cake works best when it has 3 eggs rather than 2. So he makes that change to the recipe and then commits it. A commit is when you save your changes to the branch. So now that he has saved that change, he keeps working, and he realizes that the recipe works better if you soften the cream cheese first. So he makes that change to the recipe and commits that. Now that that's saved, he keeps working and discovers that if you add 1 teaspoon of baking soda, that also makes the recipe better. So he makes that important change and commits it. Now he thinks the recipe is done and he wants to push it up to the main branch. So he decides to merge it in by creating what's called a merge request or a pull request. So this is the step where things get super, super complicated in Git. And it's where the most risk and complexities occur in the process. So let's start by talking about what a merge is. A merge is when your downstream changes get added to the upstream repository. So the process of merging in this case begins when Ken pushes his recipe upstream to the central repo and opens up a merge request. Or if you're in GitHub, it would be called a pull request. What it's called depends on which repository host you're using. If it's a pull request, sometimes you might hear people call it a PR for short. And for merge requests, you might hear some people call it an MR for short. So just know that those two terms are interchangeable. Okay, so Ken pushes up his recipe changes and pings Frida to let her know he has an MR open and wants her to review it. So Frida reviews the changes to make sure that they're of a good quality and that there are no mistakes. She also checks to make sure that all the tests are passing. Sometimes for some repositories, they might run some automated checks on merge request first, and those checks need to pass. So in this case, maybe Frida has a spell checker that runs on new MRs to make sure that there are no spelling mistakes. If this were code, it'd be like running a test suite to make sure the code passed basic quality tests. Or maybe it could be a broken link checker or something like that. So if Frida finds a problem, she'll tell Ken what the problem is and request that he make some changes. Then Ken makes the change she asked for and commits those changes and pushes that back upstream where they are automatically added to the merge request. Then he lets Frida know it's ready for another review. So she takes one more look, she does another check. She sees that everything is correct and approves the merge request. Then she merges the changes in and it becomes part of the upstream repository, meaning those changes that Ken made are now available to everybody. Everybody can see them and use them and everybody's happy. Now let's pause for a moment and just kind of talk about how cool this is. So now we have a record of all the changes that were made to the project over time. You can actually see what was changed and why. You can also see who approved the changes, and you can read the conversation that occurred about those changes during the review process. So you have a really nice, rich history of what happened in the project over time. And yes, that is a form of documentation, so that's really cool. Another nice thing is that it lets you roll back changes if you need. Let's say that Ken discovers that he wrote baking powder instead of baking soda, and Frida also didn't catch it. So now he has to roll back those changes. Git makes that pretty easy to do, or else he can just commit some new changes, and all of that is good. Okay, so let's talk about one more concept, and that's the concept of forking. So let's imagine that there's this guy named Gerald out there who really likes the awesome open source cookbook, but he kind of wants to take it in a totally new direction. He wants to make the awesome vegan open source cookbook. So in order to do that, he can fork the repo, which is like cloning, but it's usually intended to just go off and do your own thing, or at least that's how it was originally intended. So he's going to go off and make his own project now, and that's one use case for creating a fork. Hopefully you can imagine that use case. Well, there's also a more common use case for forking, and you see it a lot in open source software, and that's called the fork and branch workflow. So let's explain that one just a little bit. So the fork and branch workflow is pretty common, as I said. Let's dig into that and explain it a little bit more. Okay, first off, we need to talk a little bit about GitLab and GitHub. GitLab and GitHub are two ways to host your repositories online. That means that all the project's files, its code, and other content are stored in the cloud with GitLab or GitHub. Both GitHub and GitLab integrate very well with Git. They are not the same thing as Git. Git is just an application that runs on your computer. But you're very likely to use one of these repositories alongside with Git, because these two repository hosts add some additional features that you don't get with Git alone. For example, they provide project management tools, and they make it really easy to collaborate, especially for code reviews. And they make it easy to find new projects or to see new projects and to see what projects a specific person has contributed to. GitHub is really popular in open source communities, and the Good Docs project used to be hosted at GitHub, but in 2022 we migrated all our repositories to GitLab. So again, the basic idea here is that GitLab and GitHub are two places where the repositories can store all of its files, and you can think of them as hosting those files remotely in the cloud. So with that in mind, let's talk about how you would set up your system to contribute to a project that is hosted on GitLab or GitHub using the branch and fork method. So to start out with, let's say that the awesome source cookbook is stored in GitLab in the cloud. So let's say we also have a new contributor named Anna who wants to contribute to this cookbook for the very first time. What Anna would need to do is create a fork of the awesome open source cookbook to her personal GitLab namespace. So basically, she's making a complete copy of the cookbook that she is keeping in her own personal repository. That means she'll have a copy of all the repository's files stored in her personal GitLab space in the cloud. But how's she going to actually work on it and contribute to it? For that, she needs to clone her project to her local computer. That way she can do her work and make her contributions on her local computer. And that's how she sets it up for the first time. Okay, so once again, she makes a fork of the project to her personal namespace, and then she clones that project to her local computer. Now that you understand that, let's talk about how she can actually use that fork to contribute to the awesome open source cookbook. When Anna is ready to make a contribution to the project, she first needs to pull any changes from the upstream repository into her copy on the local computer so that she has the latest working version of the project. Okay, so let's drill in deeper and talk more about what it means to pull from upstream and push to the origin repository. So as a review, with the fork and branch method, we've essentially got three repositories. We've got the upstream project, which is stored in the cloud in GitLab in the organization space. We've got Anna's fork of the project, which is also stored in the cloud in GitLab, but this time in her personal space. And we've got Anna's clone of her fork of the project that is on her local computer. So Anna needs to make sure that all of her downstream forks and her copy in her local computer are synced up with the upstream project. That means she wants them to all be up to date and have all the latest changes. In order to do that, she pulls any changes from the upstream repository onto her local computer. Then she pushes those changes back up to her fork of the repository. So let's say that Ken contributes a new cake recipe to the awesome open source cookbook. Anna can then pull down those changes that Ken made from the upstream repository so that they are now on her local computer. And then she pushes those changes from Ken back up to her fork of the project. Now that means that the copy of the recipe and cookbook on her local machine are all up to date and they're all in sync with each other. And that's just a good habit to just regularly check for upstream updates and pull from upstream and also push to your origin fork before you get ready to make a new branch and start contributing. Otherwise, you could cause something called a merge conflict. A merge conflict is when two contributors make changes to the same file and those differences need to be resolved. So let's say that Ken and Anna made changes to the red velvet cake recipe at the exact same time. That would cause a merge conflict where Git wouldn't know which change is the most recent or accurate change. So those changes would usually have to be resolved. And sometimes that can be messy and painful to fix. But fortunately, it doesn't happen a lot. However, it is just a good practice to regularly pull from the upstream repository, ensure you have the latest changes so that you can prevent these kind of problems and merge conflicts. So I hope that wasn't too much. That was a broad overview of the fork and branch workflow in Git. So now let's change gears just a little bit and talk about why we are even talking about Git when we're talking about contributing to documentation. Well, one major reason is because a lot of organizations are beginning to adopt a docs as code philosophy when it comes to their documentation development. This philosophy is that you should write documentation using the same tools and processes as code. So that includes using things like issue trackers, version control like Git, plain text markup such as Markdown, restructured text, and ASCII doc. Yeah, using Git to do documentation reviews with subject matter experts like your coders and things like that. And also ensuring documentation quality using automated tests and linters. So there's certain advantages that come from the docs as code process. One is that docs are seen as a necessary part of the process. It incentivizes developers to think of documentation as integral and important to the software development process. As a result, it enables a culture where writers and developers both feel ownership over the documentation and work together to make sure it is as good as it can possibly be. So a lot of times that means that developers will write the first draft of documentation, which is good because they're the subject matter experts and they have a lot of context for those changes. And it's also good because, contrary to popular belief, developers can write documentation and they can do it well. So it's really good to incorporate and involve them in the process of making documentation because that improves documentation for everybody. Another advantage is that it lowers the barrier to entry because it makes it easier for developers to contribute to the documentation. It allows them to use the same kind of tools and processes that they are familiar with when it comes to code development and apply those same principles to documentation development as well. And that shift in mindset sometimes helps make documentation work feel a little more approachable and a little more doable from a developer point of view. And lots of organizations are implementing docs as code systems such as Google and Twitter, and they've seen some amazingly positive and transformative effects from implementing docs as code in their documentation. All right, well, that is basically it for your crash course overview of Git. We are super excited to have you join the Good Docs project and begin making contributions to our project. And we're excited to see you in our Git training workshop, where we'll give you some hands-on practice with some of these general concepts that we've introduced in this video. So we look forward to seeing you then. Bye-bye.